Imagine everything you've ever known. Every star, every planet, every atom in your body, compressed into a single, inconceivably tiny point. No galaxies, no light, not even space or time itself. Just a singularity, a place where the laws of physics, as we understand them, completely break down. Now picture this point suddenly exploding, not into empty space, but creating space itself as it expands outward faster than the speed of light. This is the beginning of everything. This is the Big Bang. But what really happened in those first moments? And how do we even know, billions of years later, what took place at the dawn of time? Stay with me, because the answers will surprise you and might just change the way you see the universe. About 13.8 billion years ago, the universe was born, not with a bang, as you might imagine, but with an unimaginably rapid expansion. In less than a fraction of a second, the universe grew from smaller than a single atom to something vast, beyond comprehension. This brief instant is known as the inflationary epoch. It's almost impossible to visualize, a burst of growth so fast that in the blink of an eye, distances greater than the entire observable universe today were covered. But why did this happen? And what caused it to stop? Scientists still debate the details, but what we do know is that this inflation explains two puzzling features of our universe: its smoothness and its flatness. No matter where we look in the cosmos, the temperature and structure are remarkably uniform, as if everything had once been intimately connected before being pulled apart at breakneck speed. But let's go deeper. As the universe expanded, it cooled. In those first microseconds after inflation, the energy was so intense that matter as we know it couldn't exist. Instead, the universe was filled with a seething soup of elementary particles, quarks, leptons, and the mysterious force-carrying particles that govern their interactions. Imagine a cauldron swirling with raw ingredients, too hot for anything to stick together. But as the universe continued to stretch and cool, something incredible happened. Quarks began to bind together, forming the first protons and neutrons, the basic building blocks of all atoms. For a few fleeting moments, the universe was a cosmic forge, fusing these particles into the nuclei of the lightest elements: hydrogen, helium, and a sprinkle of lithium. This process, called primordial nucleosynthesis, set the stage for everything that would come after. But the universe was still a strange and alien place. For hundreds of thousands of years, it remained an opaque fog, with energy and light trapped by a dense sea of free electrons. No star could shine, and no eye could see. But then, about 380,000 years after the Big Bang, the universe cooled enough for electrons to combine with nuclei, forming neutral atoms. Suddenly, the cosmos became transparent. Light, once imprisoned, could finally travel freely. This ancient light, stretched and cooled over billions of years, is still out there today. It's called the cosmic microwave background, and it's like a baby picture of the universe, proof of the Big Bang, captured in the faint afterglow that fills the sky. But the story doesn't end there. Slowly, gravity began to work its magic. Tiny ripples in the fabric of space, tiny variations in density, left over from the early universe, grew larger and larger. Matter clumped together, and over millions, then billions of years, these clumps became immense clouds of gas. Within these clouds, gravity pulled matter tighter and tighter, until the first stars ignited, lighting up the darkness for the first time. Galaxies formed, vast islands of stars, gas, and mysterious dark matter, spinning and colliding in a cosmic dance that continues to this day. Some of these galaxies would merge, growing even larger. Stars would live and die, forging new elements in their cores and scattering them into space, sowing the seeds for planets and eventually for life. But the Big Bang theory raises questions that boggle the mind. What happened before the Big Bang? Was there a before? Did the universe have a beginning? Or has it cycled through endless births and deaths? Is our universe just one of countless others, bubbling into existence in an infinite multiverse? And what about the future? The universe is still expanding, and observations suggest that this expansion is actually speeding up, driven by a mysterious force called dark energy. Will the universe continue to stretch forever, growing colder and emptier? Or could it one day collapse back in on itself, erasing all that has come before? Scientists are still searching for answers. using powerful telescopes, satellites, and particle accelerators to peer deeper into the cosmos and further back in time. Every discovery brings new questions and new wonders. But the most incredible part? We are all part of this story. The atoms in our bodies were forged in the hearts of ancient stars, themselves born from the primordial elements created in the first moments after the Big Bang. When you gaze up at the night sky, you are looking at a universe still unfolding, still evolving, shaped by events that began nearly 14 billion years ago. What other secrets does the universe hold? How did something come from nothing? And where will it all end? If you're as fascinated by these mysteries as I am, make sure to subscribe, because the journey to understand our cosmic origins has only just begun. There are countless wonders still waiting to be discovered, and together we'll explore the greatest questions of all. Where did we come from? What are we made of? And what ultimately is our place in this vast and astonishing universe?